After taking the quiz in part 2 of this module, what did you learn about your metabolic flexibility? The biggest room in the world is the room for improvement. And whether you already have relatively good metabolic health or not, the next 2 weeks of this program are dedicated to changes that will grant you even more freedom and control when it comes to managing your overall health. So in this lesson, we are going to talk a little about the science behind carbohydrate metabolism as well as some practical approaches to improving your metabolic flexibility. Before we jump into it, I want to acknowledge that in the world of metabolic health, not much actually happens overnight. When we are not as metabolically healthy as we would like to be, then it's very likely because there are certain daily habits that need to be addressed. If you ate yourself into a particular condition, then you have to eat yourself out of it. And I'm going to show you how to do that in this program. In order to get there, it's going to take some understanding of the problem and a hearty commitment to fixing it. Now you may be thinking, why am I looking at a picture of mitochondria? In week 1 of this program, I asked you to cut out added sugar, which converts directly to glucose. Any form of refined sugar creates a chaotic and inflammatory environment in which disease can grow and thrive. And as I illustrated with the story of the boy who cried wolf, when there is too much glucose in the bloodstream, then the glucose receptors on your cells become saturated and it becomes even harder for your cells to take up the glucose so that the mitochondria in the cells can use it for fuel. The mitochondria is the powerhouse of the cell. And when your blood becomes too saturated with glucose, it becomes very hard for this mitochondria to keep up. Imagine there's a guy working inside the locomotive of a train. The locomotive is the engine car that burns coal, which enables the whole train to move. This guy is working hard to shovel coal into the furnace in order to keep the train rolling. And then imagine there are people who keep supplying him with more and more coal. A certain amount of coal is beneficial so that the train keeps moving and he still has work to do. But before he even knows what's happening, he looks around and he is surrounded by coal inside the engine room. At this point, he can barely move, so he has to work extra hard to burn all of this surplus coal in the engine room just so he can move around. He can't handle any more coal in this room, so he starts blocking the entrance to the engine. Now the workers who are delivering the coal can't get into the fuel car, and coal starts to back up into other parts of the train where it doesn't belong. This is similar to what happens when your cells get overloaded with glucose. The mitochondria can't burn it all, so it starts closing off the receptors that would normally allow the glucose to get into the cell and serve as fuel. This is what we call insulin resistance because the hormone insulin is what triggers the receptors on the cells to open up and absorb that glucose. So while insulin calls the shots under normal circumstances, the mitochondria are like the guy in the engine room who has the power to lock the door when he gets overwhelmed. Likewise, the mitochondria have the ability to shut off the receptor cells when they get overwhelmed. This is not a good place for your body to be in. This is where a lot of chronic inflammatory and even autoimmune conditions are born. But what a lot of people don't know is that it's not just white sugar and candy that are the problem. Foods like bread and other sources of refined carbohydrates actually convert directly to glucose or sugar once they are broken down and absorbed into the bloodstream as well. An even bigger shocker is that this process actually begins once you take that first bite. And the reason for this is because the salivary glands in your mouth begin to release the enzyme that breaks down carbohydrates just as soon as your body senses that there are carbohydrate molecules in your mouth. So theoretically, you can put a piece of bread in your mouth for about a minute and not even chew. And your salivary glands will begin to release the amylase enzyme, break down the bonds between the carbohydrate molecules, convert them to glucose, and then absorb them directly into your bloodstream through the oral cavity to use as an immediate fuel source, all before you even swallow the food. But I want to be clear that the glucose molecule is not necessarily the bad guy. It simply matters how much of it you get into the bloodstream. The problem of too much glucose can actually be easily balanced with some dietary changes. Here is what glucose actually is. Glucose is a simple sugar. It is an important energy source in living organisms, and glucose molecules are linked together to form carbohydrates. Our cells use glucose in order to function. Those are the basics. Now let's talk about where glucose comes from and how we can get just the right amount into our systems without wreaking havoc on our metabolic health. Carbohydrates are one of 3 macronutrients. The other macronutrients are fats and proteins. We need the macronutrients in order to keep the body running. We can look at this picture and instantly recognize that these carbohydrate-packed items all originate from plants, and they are all sources of quick energy for the human body to consume and utilize. Carbohydrates consist of the following components: starches, fibers, and sugars. Now I want to spend some time talking about these components of carbohydrates so that you can better understand exactly what your body is doing with these energy sources and how to make the most of the foods you eat. What is the difference between starch and fiber? Starch is common in potatoes and grains. It is a soft, pliable substance that we can easily chew and swallow. Starch is made up of chains of glucose molecules. During digestion, the links between individual glucose units are broken by the amylase enzyme, which effectively creates a bunch of free sugar molecules in the form of glucose. The glucose then passes through the GI tract and into the bloodstream, providing us with a quick source of energy. Fiber, on the other hand, is a stiffer and more rigid substance, and it is the main structural component of plants. Having more fiber in your diet is a great thing because fiber lowers your blood sugar by preventing some of the glucose in your food from being absorbed into the bloodstream. That's right. Fiber is like a built-in safety mechanism in plants that prevents your body from absorbing too much glucose into the bloodstream. When you remove the fiber from foods, it becomes a big ol' free-for-all where glucose is taken up into the bloodstream way too quickly. Fiber pumps the brakes on glucose absorption. So how does this work? How does fiber prevent us from absorbing too much glucose from carbohydrates? In this illustration, you can see the structural difference between starch molecules versus fiber molecules. Fiber is also known as cellulose, so that's what it's called in this picture. The bonds in fiber, those little red lines between the glucose molecules, are chemically engineered in a way that makes fiber indigestible to humans because we do not produce the necessary enzyme called cellulase to break it down. That bond in fiber is too complex to be broken down for the enzymes that humans produce. So when we eat fiber, it passes right through the small intestine undigested. This is a really practical thing to know because it means that we have the tools to improve our metabolic health simply by consuming more fiber. And that is one of the major reasons I encourage people to stay away from consuming processed foods. Without the fiber packaging, the food becomes a thing of excess and sets the body up for chronic disease. And even though fiber can't be broken down by amylase, it's useful to know that some of the bacteria in our large intestines can actually break down fiber. Often, the end result of fiber breakdown by gut bacteria is flatulence. If you are transitioning from a low-fiber diet like the standard American diet to a higher fiber diet, then you may experience more flatulence after meals in the initial stages of changing your diet. This is because your gut bacteria or your microbiome is not yet adjusted to the higher concentration of high-fiber foods. A healthy microbiome with lots of good bacteria that are capable of breaking down plant fibers is something that you have to build up over time. You can do this by slowly transitioning to a more fiber-rich diet. Also, one thing you can do to populate your gut with good bacteria that will help you better tolerate some of these insoluble fibers is to take a probiotic supplement or consume raw fermented vegetables like kimchi and sauerkraut. If you don't know about the wonderful benefits of fermented vegetables, we'll get into that more next week, and I'll even teach you how to make your own nutrient-rich source of probiotics at home. Now that we know about starches, sugars, and fibers, it becomes apparent that not all plant-derived foods are created equal. For example, a donut can be almost completely composed of plant-derived ingredients like flour and sugar, and it is still much more chaotic to the body's blood sugar levels when compared to broccoli. Broccoli contains a lot more fiber, water, and nutrients, and has a much lower concentration of starch compared to the donut. Therefore, the broccoli is going to have a much more stable impact on blood sugar levels. Let's take a minute to talk about how we can measure the impact that a given food will have on our blood sugar. We can use the glycemic index to figure that out. The glycemic index is a number from 0 to 100 assigned to a food with pure glucose arbitrarily given the value of 100, which represents the relative rise in the blood glucose level that you experience after you consume that particular food. So how do we qualify foods on this scale? Why do we consider something to be a low glycemic food versus a high glycemic food? The glycemic index of a specific food depends mostly on how many carbs are packed into that food and what types of carbohydrates we're talking about. Like, is it mostly fiber or mostly starch? Glycemic index is also impacted by certain factors like ripeness, cooking method, type of sugar it contains, and amount of processing that the food has undergone. A food is considered to have a low glycemic index if it is at 55 or less. A food is considered to have a mid-range glycemic index if it falls between 56 to 69, and a food has a high glycemic index if it is rated at 70 or higher. Foods that are high in refined carbs and sugar are digested more quickly and often have a high GI index, like these foods, for example. Waffles have an average glycemic index of 76, which is only slightly higher than the whole wheat bread at 71. Remember, anything with a glycemic index above 70 is high and can spike your blood sugar. So you might be surprised to know that everyone's favorite breakfast food, oatmeal, has a glycemic index of 87, which is an even higher rating than waffles. Foods that are high in protein, fat, or fiber typically have a low glycemic index. These types of foods are not going to have a dramatic impact on your blood sugar levels. We are talking about things like pineapple, which has a mid-range glycemic index of 66. Coconut yogurt has a low-range GI of around 14. And dried beans that you have soaked overnight and then cooked at home have a low-range glycemic index of about 40. Just as another pro-nutrition tip, you can affect the glycemic index of some plants that are high in starch like potatoes, winter squash, and even beans by putting them in the refrigerator overnight and letting them cool. After they are cooked and cooled, the bonds between the carbohydrates begin to reform, and you end up with a higher level of resistant starch that actually lowers the glycemic load of that food. So anytime you cook your beans or potatoes, be sure to cool them in the fridge overnight. This trick still works even if you reheat those foods before you eat them. Foods that contain no carbs are not assigned a glycemic index, and that includes things like meat, fish, poultry, nuts, seeds, herbs, spices, and oils. So these foods won't spike your blood sugar at all. Let's compare two different types of breads to understand more about how their contents affect their glycemic load. There are so many varieties of breads out there, but let's just use a plain white bagel for example. It has a glycemic index of around 95. That is higher than even a bowl of white rice. Basically, this means that as soon as you put this into your mouth, amylase starts to go to work, breaking it down into sugar molecules. It's essentially like injecting pure glucose into your bloodstream. On the other hand, let's take a slice of sprouted grain bread like the Ezekiel brand that you can find in most grocery stores in the frozen health food section. A slice of this 4-9 whole grain variety of Ezekiel bread has a glycemic index of 36, which is mostly attributed to the higher amount of protein and fiber in the bread. A glycemic index of 36 is significantly lower than 95, which is much better for your long-term metabolic health. So if you are in the grocery store and you are shopping for a type of bread that you want to buy in order to make a sandwich, go for the Ezekiel 4-9 bread. Ultimately, what all of this boils down to is that I want you to be mindful of the processed and refined carbohydrates that you're consuming. Become aware of anything you consume that converts quickly into sugar and begin paying attention to how it makes you feel. In the next lesson, I'm going to address some of the health issues that arise from chronic blood sugar dysregulation so that you can start to connect the dots between how you feel and what you eat. The hope is that as we start to include more fiber-rich foods into our diets, we naturally start leaving behind the refined carbohydrates.